evening, guys. Good evening. Thank you for joining for another live session. How you all doing? How was your day? How was your coding thing today? I know it's a working day, so I'm sure you guys face lots of challenges and hopefully got some quality code out. So myself, I was working on today. Let me think. Yeah, some of the validation logic, some of the mapping logic. I'm trying to generalize, guys. I can't just tell you the exact, it's down to the company policy. So it's just generally some mapping logic, validation logic, a little bit of research on the side. Yeah, it's going well. So so hopefully, I'm sure whoever joining today, you guys also have kind of a bit of passion about doing some tech stuff. So let's make this session short, guys. Yeah, because I'm sure you guys are tired and I'm tired as well, of course, because after being working through the whole day from 9 to 6. So today's topic is erase structural types. So guys, like I said in the last session, this TypeScript for Java and C# programmers I found really interesting because I don't know whether it's probably because my background, I initially started many years ago studying Java. So probably that's the reason, because I kind of have this nominal type system sticking to my head, and most of the languages I worked on, Java, Scala, mainly C# and all those languages, we had this type system attached to that. We know, like when you have a name with the class or an interface, this one type, and we have the base type. So all these interconnection between the types. So this specific the guide TypeScript have given to us is for engineers who are coming from that kind of nominal type background. So which is awesome, because we can kind of learn the structural typing, duck typing concept very easily by just following this short guide. It's very handy. So rather than jump into the handbook or other references, I feel it's really good, handy guide. So I found it very interesting. I hope you guys do. I'm sure you guys already gone through the guide as well. And I know many going through the JS programmer section, like for the JS programmers TypeScript part. Even myself, I started from there. But I highly recommend if you can have a 5 minutes, 10 minutes spent on the Java C# programmer section as well. You will find some interesting stuff. So guys, I'm sharing today as well because I found the erase structural types section. Because as we know, because in the TypeScript we only have all the types intelligence only at the compile time, the development time, and it compiles down to the JavaScript. It's good performance, another high level language. But all these type manipulations we are doing, these conditional types, all these interfaces, type, what else we are using, classes. Classes are, we get the instance objects, but all these type specific, like the intersections and all these sets concept in the type using, and the utility types, all these informations are going away once it's come down to the JavaScript file. But still it's worth it, because as we know, in the JavaScript the biggest problem was we had lots of potentially we get high rate of bugs in runtime. So adding this layer of TypeScript gives us a good control, especially when you're writing the code in the editor. It gives us the instant feedback, which is kind of handy, because we can focus on more the core logic of solving the problem, rather than worrying about the would that object have this property or method. And I found it very interesting and very productive when it's come to writing code, especially coming from the JavaScript. If you're coming from the JavaScript background, you will definitely appreciate what TypeScript gives us. So guys, let's focus on this section, erase structural type. So what it does is actually, the summary is that all the types information, the structural type information, this keyword is very important, and we'll go through the example and see as well. So those information will be erased, so they will go in a way when it's compiled, or when it's compiled down to JavaScript. So we won't have any kind of like a reflection API or something like in the nominal type languages. We won't be able to look for the type when it comes to runtime. It will be same JavaScript stuff. So every decisions you are making through the types, you have to do it during the compile time, and TypeScript nicely convert that to the appropriate JavaScript code. So guys, let's go through this section a little bit, what it's trying to tell us. The key point I found here, in TypeScript, objects are not of a single exact type. This is a very crucial point, guys, because even for me when I started, I found it a little bit confusing, because one object can belong to many types. In other words, set of type, I would say. I mean, that's how the TypeScript also asking or encouraging us to think in terms of the types as sets. So that will give us a more broader view about the type system. And definitely one object would not map into or belongs to one type. It will belong to many types, because it's structural typing. It's not like based on the name. And we'll see some of the examples, but that single line delivers a very core meaning of this type system. So I will just repeat that again. In TypeScript, objects are not of a single exact type, right? And they give an example as well. If we construct an object that satisfies an interface, we can use that object where that interface is expected, even though there was no declarative relationship between the two. I think we should highlight that bit as well, guys, because declarative relationship, like extending something or something like, which makes sense us looking at the code. We see the relationship between those two types. But it says what it says in the documentation, it can be still belong or satisfy particular type, one object, even though those types don't have any kind of a declarative relationship, right? So we'll jump into this example, the example they have given. It's taking a bit time. Then downloading TypeScript, we'll see. Let's give it a minute. I don't know why it's showing. It's probably we are streaming, right? So that might be the case. Here we go. Yeah, here. Finally. And let's go through this example. So we have this interface point like. We got X and Y coordinates. And we have another interface called named, which has name string. And we have log point, which takes a point like, and we got a console log X and Y. And we have another function log name, which gets named. And we have this particular object. And guys, we are passing the same object for both functions, log point and log name. Before we go into the detail, let's go and have a look at the JS code, guys. That would be interesting. Let me check if you guys can see that. Yeah, so if you see here, the thing that they mentioned in the documentation about erasing types, we can see here. Now we don't see interface point like here. We don't see interface named. We don't see in the this log name or log point function the interface are tagged, or the type annotation is not there. They all gone. So that's the erased part, as per my understanding. So it's erasing all the structural type information when it's compiled down to the JavaScript. So that's to say, we feel like there is no runtime safety there, because if you're thinking that, we still need to manage the runtime safety when you're writing the code. I would say the compile time coverage is there. but the logic should be still there. So I mean, we can't forget JavaScript, in another word. So we just have to follow the same JavaScript rules. So TypeScript will only provide us some extra security or improve or boost our productivity by giving the type information, so we can, get rid of lots of human errors, I would say, as programmers. So yeah, that's interesting to see. So what it compiled down to. So now we can understand today's topic, like erase structural type. So erase part, I think it's clear to me. I hope you guys as well. But if you have more information, feel free to share, guys. This is a sharing session, so I would like to learn from you as well. So if you know anything extra, please share, so everybody can learn something. All right, so guys, let's go back to the code. So we have the point like here, and in this point like, so this particular object, we can see name only need name part, and this object satisfy that. And the point like only needs x and y. Of course, it has some extra property, but for the point like function, it only needs something that has x and y, and we have it, and that satisfy that interface. So this object belongs to what type? Right, I mean, it can be used as named, it can be used as point like, so it belongs to set of type, not to a single type. Of course, we need this naming, because that's one of the benefit we get from TypeScript. Is more expressive, or it's more easy to maintain, because we know this is point like interface, and we can tag that type as a parameter type, return type. So that value is there, but we need to understand what's happening on the line, and how this type system understand, or TypeScript will see this as object is belong to type. So I mean, we shouldn't be surprised by seeing that we can pass this object into point like. But I'm wondering now, if we had this point like, let's get some sort of another interface merging these two. I know we can do it using some syntax, but I would just make it straightforward here. So this is like a combination of named and point like. Now I would like to tag it here saying point like named, right? Now this object is belong to point like named, but still we can pass that object into this point and name. So this object point like name type, but we are using that same object in log name and log point. So this object is not belong just to point like name, it belongs to named and point like types as well, because it's structural typing, duck typing. Just look at the properties. I'm using the property term as broader, like values and functions within an object. Or if we just say properties are just the values or data, then we can say the functions as well or methods. So all of them are matched based on name and type. So this is interesting, guys. So I think this point, if we try to understand, I think it will open up our horizon into more depth of TypeScript and its flexibility, as well as the way of understanding without type. So we shouldn't be surprised by seeing that we can use one type of object with another type or set of types, because it's only looking for, TypeScript is only looking for whether that particular object would satisfy a type. So in this case, point like name satisfy named, and point like, so it's happy to accept that object with no errors. So guys, yeah, I think hopefully, this session we had today gives us, for me definitely it's helpful, because I'm sharing with you guys as well, so I definitely learned it more, and hope you guys found something interesting as well. So if you find anything, if I missed, if you feel please feel free to share so I can learn from you guys as well. So let's go back to the documentation and just go through after that example what it says here. So it's pretty much what we discussed. So TypeScript type system is structural, not nominal. So guys, I think even those two words having distinguished understanding is really cool. So structural is the structure type or duck type, and nominal type is we know if the same properties are there, if the names are different of type, they take as different types. But we can achieve that in TypeScript as we will discuss in another live stream. But mainly we need to understand that TypeScript type system is structural and one object can belong to a set of types. And it says we can use object as a point light because it has x and y properties, and the relationship between types are determined by the properties they contain. So I think in here the properties, if somebody is watching, if they're new to TypeScript, this properties means values and functions, guys. So properties are kind of a broader term they're using, because at the end of the day, even a function is a property as well, because you will use log, colon, and the function implementation. But I like to keep the terminology straightforward, otherwise little confusions can happen. So by the properties they contain, not whether they were declared with some particular relationship. So relationship is not important in this type system. It's all down to the properties, right? Between two types are determined by the properties they contain. So the relationship between two types are determined by the properties they contain, not whether they declared with some particular relationship. It's not about having extend and all kind of things. It's more about down to the properties, right? And also there's a types in type system is also notified. There's nothing at runtime that will tell us that object is point like. In fact, the point like type is not present in any form at runtime. Going back to the idea of types as sets, guys, this is the core between two types as set. We can think of object as being a member of both the point like set of values and the named set of values. That's really cool, guys. So types as sets. So that's the mindset shift we need to make. I mean, we still could understand, but I like to have good understanding of the type system so we know what we are doing, not by accident. Because sometimes something can work and we feel like, oh, it's working, so no errors on the TypeScript, and we probably just passing, I don't know, let's say one type to another type, and it works. I mean, we might be, that might not was our intention. We might be making a mistake because not understanding properly this types as sets, or the properties, how determine the relationship between object and types, that concept. So we can avoid that kind of misunderstanding or some sort of unknown, not intentional things we were trying to do but still work kind of situations in our code. If we understood this, or at least we are trying to understand by doing this kind of session and trying out the example to further understand in the type system. And that's kind of the main idea, guys. That's why I'm trying to jump in and look for these little part of within the documentation that talks more about the type system. I mean, I found in the TypeScript is scattered everywhere you find about the type system. Like these points, I got more understanding by referring to this Java C# programmer section rather than looking at the handbook. And also we kind of start to appreciate why we need all these type manipulation utilities and everything, because sometimes initially I feel like, why, I mean, I had the same dilemma, why we need these all kind of type manipulation? We can just create a new type. But having a base type, and from the base type we use some utility to construct the things, will give the best benefit out of the type system of structural. That's what I felt. And that way we can make some sort of relationship, hidden relationship, and for our brain it's easy to understand, even though the reality is that all the relationships are based on the determined by the properties types contain or object contain. And also we need to think that types as sets. So one object can belong to or satisfy more than one type. Kind of a mindset would help. Alright guys, I think this is enough for today, isn't it? Because we have a long day as developers. I'm sure you guys are tired as well, and we need to get another start for tomorrow. So yeah, thank you very much for joining this live stream, and yeah, please share your knowledge, and I would like to learn from you as well. So anything you know more than this, if I made any mistake, please let me know. So yes guys, so we'll find another section of the documentation and we'll go through another live stream. Thank you again, and have a good night guys. Cheers.